Effect of water table on the effective stress. Let's consider a soil element at a depth h from the ground level and z from the water table. Then we obtain the total stress as gamma into h, where gamma is the density of soil. And we obtain the pore water pressure as gamma W into z, where gamma W is the density of water. The effective stress is obtained as total stress minus the pore water pressure. Let's compute the effective stress for different cases. For that, we will take the density of soil as gamma, submerged density of soil as gamma sub, saturated density of soil as gamma saturated, and so on. The first case is for the dry conditions, that is, there is no water table. Since the soil is dry, the density of soil is taken as gamma d. Now let's consider two levels, L1 and L2. L1 is at ground level and L2 level is at a depth h from the ground level. At L1, since there is no soil or water above it, the total stress, the pore water pressure, and the effective stress is obtained as 0. Now at level 2, that is L2, the total stress is obtained as gamma d into h, and pore water pressure U will be obtained as 0 since there is no water above it. Therefore, the effective stress will be gamma d into h. Case 2. When the water table is at a depth h1 from the ground level. So h1 is the depth of water table from the ground level and h2 is the depth of level L2 from the water table. Now let's consider the level L1. At L1, since there is no soil or water above it, the effective stress is obtained as 0. Now when considering L2, we obtain the total stress as gamma into H1, which is for the soil part is that is above water table, plus gamma saturated into H2 when we are considering the soil below the water table up to the level L2. The pore water pressure is obtained as gamma W into H2. Therefore, we obtain the effective stress as gamma H1 plus gamma submerged into H2. Since we know that gamma saturated minus gamma W is the submerged density of soil. Now let's consider level L3. At L3, the total stress is obtained as gamma into H1. Now since there is no water above that level, U, that is the pore water pressure, is obtained as 0. Therefore, the effective stress gamma dash is obtained as gamma into H1. Case 3. Water table at ground level. The depth L2 is h from the ground level or the water table. Now considering level L1, again total stress, the pore water pressure and the effective stress is 0. Now when considering level L2, the total stress is obtained as gamma saturated into H. We are taking gamma as gamma saturated because the water table is at the ground level. We have the pore water pressure as gamma W into H. Therefore, the effective stress, which is the difference between the total stress and the pore water pressure, we obtain as gamma submerged into H. Case 4. When the water table is above the ground level at a height h1. Again, let's consider three levels, L1, L2 and L3. L1 is ground level, L2 is at a depth h from the ground level, and L3 is the height of water table from the ground level. L1. At L1, the total stress is gamma W into H1. That is, we will consider the weight of the water that is acting above it. The pore water pressure is again gamma W into H1. Therefore, the effective stress will be 0. At level 2, the total stress is obtained as gamma saturated into H, that is when we are considering the soil part, plus gamma H into H1 when we are considering the water component. The pore water pressure is obtained as gamma W into H plus H1. Therefore, the effective stress is obtained as gamma saturated H plus gamma WH1 minus gamma WH minus gamma WH1. Therefore, we will get effective stress as gamma submerged into H. Now, when considering level L3, since there is no water above it, the total stress will be zero, the pore water pressure will be zero, therefore, the effective stress will also be zero. It will be good to remember the following points. The dry density of soil is much greater than the natural density of soil. That is, the soil is having some moisture content, which will be much greater than the saturated density of soil, which will again be greater than the submerged density of soil. When we only consider the magnitude of effective stress at level L2 for all the cases, it is good to note that for case 1, the magnitude of effective stress at L2 will be greater than that of case 2, which will be again greater than case 3 or 4. When water table rises from a lower depth to the ground level, the effective stress will keep on decreasing. While when the water table rises above the ground level, no matter what the fluctuation of water table be above the ground level, there is no change in effective stress at a particular depth below the ground level. Thank you.